We've seen many questions over the last couple of weeks involving external forces. External forces are forces that act on the outside of a system. We have three external forces in the question that you see up on the board right now, a question that you have on a handout that I gave you a few days ago. That's an external force. It's a force of friction acting on the 10 kilogram object, between the 10 kilogram object and the surface. We'll call that FF1. There's another force of friction that we'll call FF2 that acts between the 15 kilogram object and the surface. And then we have an applied force we're calling FA of 50 newtons that's pulling the system to the right. All three of these forces affect the motion of the entire system, the 10 kilogram object and the 15 kilogram object together. But what if we want to find the force that acts between the 10 and the 15 kilogram object, the force of this rope that joins the two objects together? We call that an internal force. Specifically, because it's a rope that joins the two together, we'll call it FT, the tension between the two objects, the tension of the rope between these two objects, the 10 and the 15. What's the strategy that we use to solve this problem? Well, the good news is, for the most part, you know how to do this question already. We have to first analyze the system. And that's what we've done up until now, is analyze the system. So the first part of this isn't going to be any different than what you've already done. To analyze the system, we draw a free body diagram, which we already have drawn here. And then we set F net equal to the sum of the forces, as we always do. Three external forces here. That's FF1, FF2, and the applied force, FA. Now, the net force is also equal to m times a, the mass times the acceleration. What mass do we sub in here? Well, we sub in the total mass, as we always have. 10 and 15 make 25 kilograms. The total mass always goes on the left-hand side. We're going to first solve for the acceleration of this system, sub in negative 20 newtons for FF1, because it's force of friction to the left, 25 newtons negative, because it's to the left as well. And the applied force of 50 newtons on this system is to the right. So we're going to make that positive. When we add those numbers up on the right-hand side, then divide by 25, we get an acceleration of the system of 0.20 meters per second squared. This is not new. We've done this many times before. What we're about to do is a little new. What we're about to do is to find that force of tension that acts between the 10 and the 15, the internal force, as we call it. To do that, we have to analyze an individual object, one object. So remember, on the left-hand side, we were analyzing the system. Now we're analyzing an individual object. You can pick whichever object you want, the 10 or the 15. I'm going to pick the 10. Let's draw a free body diagram for just the 10 kilogram object. There is a force of friction acting to the left. We call that FF1. Its value is 20 newtons. Now, there is a force of tension between the 15 and the 10 that pulls on the 10 to the right. Think about this. If we apply a force of 50 newtons to the right on the system, in order for the 15 and the 10 to both move to the right, there has to be something pulling on the 10. And that's the force of tension the 15 is pulling on the 10 with. Now, we're not going to include the 25 newtons here, because although that's a force acting on the system, it's acting directly on the 15 kilogram object, not the 10. The 50 newtons is also acting directly on the 15, not the 10. So the only forces we want to include here are the 20 newton force of friction that acts directly on the 10, and the force of tension that acts directly on the 10. Now, we're analyzing this one individual object in the same way as we would analyze the system. F net is equal to the sum of the forces, FF1 plus FT, the force of tension. F net is m times a. That's going to be this time 10, because remember, we're only analyzing the individual object. Its mass is 10 kilograms. The acceleration is 0.20 meters per second squared. If you think about that, the acceleration of the system is 0.20. The acceleration of each individual object within the system must be 0.20 as well. FF1 is negative 20 newtons. and Ft, the force of tension, is going to be what we're looking for here. 10 times 0.2 is 2 newtons. Take the 20 newtons over to the other side by adding, and we get a force of tension here of 22 newtons. Now, I said when we started the right-hand side here, the individual object, we could have picked the other object, the 15 kilogram object. If we did, we would have gotten negative 22 newtons because the tension would have been pulling back on the 15 kilogram object the other way. Same number, opposite sign, doesn't really matter which one you get. Analyze the 10, get positive 22, the 15, get negative 22. Okay? Both are acceptable. Let's take a look at the next one now. This is real similar, different numbers, but real similar. We have two objects again. The system has a mass of 20 kilogram. Each individual object is 12 and 8. In order to find the force of tension in the rope that joins the two, this force right here, how hard the 8 pulls on the 12, then what we want to do is analyze the system first, and then analyze the individual object next. So let's do the system. Let's say for the system, F net is equal to the sum of the forces. That's FF, we'll call that FF1, FF2, plus the applied force, whatever is pulling on this with a force of 45 newtons to the right. The net force is m times a. The mass we use is the total mass, 20 kilograms, times the acceleration equals negative 18 plus negative 12 plus positive 45. Add those up on the right-hand side, divide by 20, and we get an acceleration here of 0.75 meters per second squared. The acceleration of the system and of each individual object within the system. Now let's pick an individual object. We could pick the 12 or the 8. Last time I picked the one on the left-hand side. This time I'll pick the one on the right-hand side. That's the 8 kilogram object. Again, it doesn't really matter which one you pick. They both give you the same answer. On the 8 kilogram object, we have a force that's directly acting on it with a value of 45 newtons. That's the applied force. We also have an FF2 acting directly on it. Its value is 12 newtons. And the other force we have acting on it is the tension acting, the rope pulling back on it to the left. The 8 pulls on the 12 to the right. The 12 pulls back on the 8 to the left. We'll say F net is equal to the sum of the forces, Ft plus FF2 plus Fa. Remember, we're not going to include FF1 here because FF1 acts directly on the 12, not on the 8. And we chose the 8. We could have chosen the 12. We chose the 8. The net force is mass times acceleration. In this case, the total mass is 8 kilograms because we're analyzing only the 8. The acceleration is 0.75. System, but also the acceleration of the individual objects within the system. Ft plus negative 12, that's FF2, plus positive 45 newtons. Now, 8 times 0.75 is 6 newtons. Negative 12 plus 45 is 33 newtons. We're going to take that 33 over to the other side by subtracting, and we end up getting a value of negative 27 newtons. That's correct. If we had have chose the 12 kilogram object to analyze, we would have gotten an answer of positive 27 newtons. It doesn't matter which you get, both are correct. Now what I'd like you to do is take a look at the 2-question worksheet titled Internal Forces Worksheet. Show all of your work. Use these examples as guides, as recipes. Keep them in front of you as you're doing those 2 questions on those worksheets. Do your best, and we'll take a look at those tomorrow.